Fine, that's what happens. So I is a amide. Which amide? I is a benzamide. This is what I is. This is my P. Fine. So this is I, and see, you are getting D from I. This is D, and this is I. From benzamide, you are getting aniline. This C double bond O is going away, and this benzene ring and this amine ring are coming together. When did this happen? When does this happen? In which reaction does this happen? C double bond O goes away, and this amine and this other part comes together. Remember, this is which reaction? Hofmann bromide reaction, isn't it? So this J is a reagent which carries out Hofmann bromide. And which reagent is that? That is NaOH and Br2. This is what J is. Fine, happy, we have done it. And if you were able to solve all of them, my heartiest congratulations to you. If you were not able to solve all of them, if you were able to miss some of them, then think of why you missed it, whether you didn't know that reaction. If you didn't know that reaction, no problem, just go and study that reaction. If you knew that reaction and still you could not get it, then that's a problem. Then do one thing, practice more than what you have been doing. So this conversion problem is there. Even if you were able to solve all of them, just note down this conversion problem and solve it after 5-10 days once again and see if you're able to do it now. Okay then, courteous reaction is done. Let's move towards the last reaction for method of preparation of amine. Let's very quickly go through the mechanism of this Schmidt reaction. This is a mineral acid. This mineral acid will produce H plus in the system. That H plus is going to be protonated here. This OH is going to turn into OH2 plus. Water is going to come out. You're going to have a selenium ion. Fine. This is the first thing that's going to happen. This selenium ion will now be attacked by hydrazoic acid. Like this. This nitrogen is going to attack this carbon. So you are going to get there's a plus charge on nitrogen because nitrogen has given its electron to carbon. That plus charge is removed when H plus comes out. Now here you have a very good living group. To facilitate its removal, you have to develop a plus charge on this nitrogen. First of all, you have to break this bond. If you break this bond such that this nitrogen gains a plus charge, then this N plus and this N minus will form a bond among themselves like this. When you give plus charge to this nitrogen will have a negative charge. Fine. Now you have a brilliant living group standing in order to leave. Now to facilitate its removal, this nitrogen gas will come out as a neutral gas. So this N plus have to be neutralized. So if you pour in the electronic wave of this bond into the orbital of nitrogen, then that will be neutralized. But simultaneously, this nitrogen will start to have a plus charge polarity. Although the whole removal will not take place in one step without other things happening, but considering that it happened, just for the sake of understanding, suppose this N2 gas comes out, then this nitrogen will gain a plus charge because the electron of this bond is going away with N2. So this becomes a neutral unstable species called carbene, which we saw when we studied Hofmann bromide. So this is highly unstable. Now a pure carbene is not formed because simultaneously this R group starts migrating to this nitrogen. So what forms is this isocyanate, which we have seen before. And what happens to this isocyanate we saw in Hofmann bromide, we saw in courteous reaction, and the same will happen in Schmidt reaction. Then this isocyanate will now undergo hydrolysis to give you this amine and this CO2 gas. From here the story we have heard before, so no repetition. Fine. This is what happens. You take an acid, you get an amine like this. Easy. Now if you're carrying out Smith reaction on a carbonyl compound. Let's take acetone. You are carrying out Smith reaction. You added hydrozoic acid. Now, what will happen here is you're also taking a mineral acid like H2SO4 in order to protonate this carbonyl group, because it's this nitrogen of hydrozoic acid is not a good nucleophile. So it will not be able to attack this C double bond O, as we have discussed before. Weak nucleophiles do not attack C double bond O because C double bond O is a goddamn stable double bond O of organic chemistry. So in order to help this azide attack this C double bond O, this mineral acid is added to weaken this C double bond O. How does it weaken the C double bond O? By protonating it. Oxygen gives its electron, oxygen develops a plus charge, oxygen starts to pull up the electron with this double bond O, and carbon, because of this whole process, develops considerable plus charge polarity, so that even a weak nucleophile can now come and attack. So looking at the opportunity to attack, this nitrogen finally got the opportunity with the help of this mineral acid. So this attacked this carbon. What happens when this attacks this carbon? This is what you get. This OH and this H will go. How will they go? They will go by removal of water. Fine. When they go, this carbon and then this nitrogen forms a bond among themselves. No problem up till now. Now simultaneously I'm breaking this bond as well. When I break this bond such that there's a plus charge on this nitrogen. Fine. When I break this bond such that a plus charge starts to build up on this nitrogen and this nitrogen forms a bond. Fine. So let's see what happens. This is what you will get. No problem. Now you have to facilitate the removal of very good leaving group. Now this leaving group will go as a neutral N2 gas. So in order to neutralize itself, nitrogen will take away the electron of this nitrogen. So this nitrogen will be electron deficient. Nitrogen is electronegative atom. It cannot be electron deficient. So this methyl will migrate to this nitrogen. When this methyl migrates to this nitrogen, this carbon develops a plus charge on it. This water, which came out in the previous step, will now come and attack this carbon. This kind of mechanism, the whole thing, I'm going a little fast because we have seen the whole process in Bakeman's rearrangement. This kind of migration of methyl from carbon to nitrogen. In the next step, water comes and attacks this carbon. We have seen this and we had enough practice before. So I can go a little fast. What we get is this. I'm so sorry. This is what you will get. Alright, this methyl came to this nitrogen, this carbon develops a plus charge. Now water molecule will attack this carbon, form a bond, and this carbon will have now a OH attached to this. So what happens next? This is what you have. Fine. There will be tautomerism now, and this double bond will come here because C double bond O is more stable than C double bond N. So C double bond O will be generated. This hydrogen will shift from oxygen to nitrogen. And this is the amide we were looking at. So this is what we have. So effectively, we started with acetone and this NH has been inserted between C double bond O and methyl. Now, carefully look at this intermediate. Because this is parallel, this methyl is parallel to this orbital, so this methyl group migrated. Now here I took a symmetrical ketone. These would have been could have been different as well. Suppose this is a R group. Fine. If this is a R group, then this methyl is migrating. Now the intermediate that was there, before this was formed was this. Now before the double bond is formed, when the double bond is formed, during that process, either R or this methyl, any one of them could have been parallel to this orbital. If any one of them could have been parallel, any one of them could have migrated, and any one of them could have been migrated, then this NH can be inserted between any one of them and this C double bond O. So this NH was not inserted between C double bond O and that group which has greatest migratory aptitude, but it could be inserted between any one of them, and there will be two possible products of this Schmidt reaction if you're carrying out Schmidt reaction on a carbonyl compound. This is the point I want to make. So just to underline the important things of this reaction, if you have a ketone, symmetrical, unsymmetrical, whatever, you are taking hydrozoic acid along with a mineral acid, then you will have two possible products. NH will be inserted between any group and C double bond O. NH can be inserted between CO and R dash, CO and R, between any one of them, and there will be two possible products of a Schmidt reaction when you are carrying Schmidt reaction on a carbonyl compound. That's what it is. That's the mechanism. This is the name. This is the substrate, reagent. This is the products. This is what you have to remember. All right. So the reactions concerning the preparation of amine are done. Now we will move on to the reactions of amines or amines, whatever you call it. Before we do that, let's solve a very little small cute problem. Now just to reinforce what I was saying verbally through this conversion problem, find out A, B and C. Do it quickly. An ideal time for a good student to solve this problem would be a minute. Let's see who's good among you. Solve it. Take 60 seconds to solve it. See if you can do it. Alright, I'll not wait for 60 seconds, and I hope that you have given 60 seconds and then you're listening to me, because you have this benefit of this virtual class that you can stop your teacher anytime by one click and then resume him. So capitalizing on that benefit, let's resume the discussion. This is C. Which reaction is this? This is Hofmann bromide, it seems. Hofmann bromide, then C would be benzamide. This is what C must be. Easy, simple. This is C. Now you're adding hydrozoic acid, you are getting two products. Hydrozoic acid is used in Schmidt reaction. Schmidt reaction is done either on acid or in carbonyl compound. When you do it on acid, you get one product, only amine. You don't get two. And you don't get amide as the product. You get amine as the product. When you carry out is on carbonyl compound, then you get amide as a product, and here you have amide as a product, and you get two products. So, and we know that what happens, NH is added between CO and a group. Here you can see NH2. So you can see it like this, that NH has been added between hydrogen and phenyl. So this is one of the products, C. So other one will be the one in which NH will be added between C double bond O and phenyl. So to get B, just add NH between C double bond O and phenyl. This must be your B. And you're doing it on carbonyl compound, right? So A will have no NH. So just remove NH. A will be B and C free of NH. This is what A will be. Easy. So I congratulate you on finishing the first phase of this chapter. We have studied the reactions concerning the preparation of amine. Now we will move on to the reactions of amines.